Welcome to today's edition of The World Today on leading the world in semiconductor design, insights from industry. Today's discussion is going very small, down to the nanometer, because our panelists will be covering the semiconductor industry. You've almost certainly read something about semiconductors over the last couple of years due to a major supply shortage and their role in US-China competition. Our speakers will focus on the design side of the semiconductor industry and how to connect that to the supply chain of semiconductors. Thanks to our panelists that are here in person and our moderator, Regina Abrami, who'll be moderating today's discussion. She is the Shangtung Term Professor and Faculty Director of Global Programs at the Lauder Institute and a senior lecturer in political science. She's going to introduce today's panelists. After she does that, we'll have some opening remarks, followed by a conversation. Thanks, everybody, for joining us today, and the floor is yours.
Thank you so much, Mike, for that very kind introduction, and thank you to all in the audience, as well as for those watching us virtually. I'm just delighted to be here today, and I'm delighted to see such a strong turnout. Let me begin first by introducing immediately to my left is Melissa Flagg, who is a visiting fellow at Prairie World House and is the founder of Flagg Consulting, LLC, in addition to being a senior advisor at the Atlantic Council's Geotech Center. She's also a fellow at the Acquisition Innovation Research Center at Stevens Institute of Technology. To my far left is Rahul Kapoor, who is the David W. Hawk Professor at the Wharton School at the University of Pennsylvania. And in his research, Professor Kapoor focuses on the management of industry disruption and ecosystems related to new technologies and business models. Looking now to our colleagues joining us virtually, hello. Allow me first to introduce Marc Facilier, who is the Senior Vice President of Technology and Product Engineering at AMD. And he is responsible for end-to-end foundry technology and engineering for new product introduction and manufacturing. And last but not least, a welcome to Raghib Hussain, who is President of Products and Technologies at Marvell, where he oversees the company's businesses and technologies by defining the strategy, aligning roadmaps, monitoring and prioritizing product development, leading innovation, and driving growth. For our two panelists who are joining us virtually, should you want to jump in on a comment or a question, I will ask if you could just raise a finger. It's probably the easiest way for me to see you. And this way, I'll just keep an eye on you while also taking a look at our other panelists here. So our format for today is for each of our panelists to make a 2 to 3 minute opening statement, after which I will sort of engage in a short conversation of about 15 to 20 minutes or so. I understand that I'll be getting signaling on timing, and then we're going to switch it over for Q&A. So I want to thank you again for your participation, both to our panelists and to our audience, virtual and here in person. So without further ado, I would like to turn it over to you, Marc, first for your initial opening statement. We will then go to Raghib, and then over to Melissa, and last but not least, Professor Kapoor. Marc?
All right. Hey, thank you, Regina. And let me first say it's great to be with you here today. And thank you to the University of Pennsylvania and the Prairie World House for hosting us on this panel. And what's a very important topic, both in our industry, but also in the world. Just reflecting, it's quite a dynamic time right now in the world and in the industry and semiconductors. But just thinking back over the last 50 years, it's amazing the heights we've scaled as an industry with just the technologies that we've been able to deliver generation on generation, and the products. If you think about the products that we have, over that 50 years, have really changed the world, and that's really a testament to the type of research and engineering that happens on a day in, day out basis in our industry. But with all that progress, and I know it's probably said oftentimes as we go through that time, it seems like over the next 10 years, we face quite a few challenges and quite a few questions, right, as we move forward. First of all, I think as we continue to develop leading edge technologies, it's becoming increasingly costly to design and to manufacture on the leading edge. It's increasingly becoming technologically challenging just to find the solutions that work as we continue to scale. If you add to that the geopolitical challenges, the challenges in the supply chain that we've had with the pandemic, it really creates a time where there are many, many questions about semiconductors and where do we take the industry forward. You know, the interesting thing is never in that time have our customers been more reliant on us to continue to deliver scaling. If you look at the progress that we've made in digitizing the economy, you know, the cloud infrastructure, you know, many of the consumer products that are now part of everyone's lives, it's really important that we continue to deliver solutions that make people's lives better, that continue to scale the energy requirements that power our world. And really, the industry is facing a time where we're going to have to make a paradigm shift in how we design our products, how we manufacture our products, to really deliver those solutions. And I think that's some of the things that we need to talk about. What investments are required to allow that paradigm shift to happen? What are the right skill sets that we need to develop and train and diversify our workforce with? And how ultimately, how do we work together to ensure the safety and security of the technologies and the products that we're delivering into a world that, let's face it, is challenged right now with the geopolitical climate. So I look forward to having those topics that we talk about here as a panel. And again, thank you for inviting us into the panel.
Thank you. Allow me to turn it over to Mr. Hussain.
Thank you. Thank you very much for inviting to this panel. And this is, I think, the great time to have this discussion because if you look at semiconductor, it has been like a foundation for all the technologies, but for the longest time, it is taken granted. And I think the recent geopolitical issues and supply chain issues, it's kind of making everybody paying attention to this. Now, as I said, it's a foundation of the technology. All the need of information and the complexity of compute and networking and storage and every aspect, which is driven by that data, you know, in today's economy, is required more and more complex technologies, and that is why the importance of semiconductor is going to increase every day a lot more. We at Marvell actually focus on the infrastructure, you know, data infrastructure, which really includes the enterprise, cloud, you know, carrier network, 5G, as well as you know, edge and automotive. If you look at all these, you know, and infrastructure, they are all, you know, facing a exponential increase in data. And of course, this data needs to be stored, needs to be processed, needs to be secured, needs to be moved around for sharing and all that. And this is what we focus on at Marvell. We solve the infrastructure problem through our products and storage, networking, you know, interconnect like electro-optical interconnect, security, and compute. Now, as we go forward in serving the needs of these markets, we have to focus on the exponential increasing requirement in each one of these areas, which is bandwidth increase, compute increase, security requirement increase, as well as storage increase. But we have to do it with the mechanism so that it is environmental friendly, which means we have to make it more and more optimized for power efficiency, as well as it has to be optimized for cost efficiency. So that is why the amount of investment needed to in developing the what is called the next generation or latest you know, semiconductor technologies, and not only on the manufacturing side but also on the architecture side, and make it more optimized for the end solutions. The need of those kind of products are increasing every day. And this is where a lot of things that we are doing, you know, to bring the best semiconductor for the infrastructure. But this is an area where whole industry has to start focusing a lot more, and we have to work collaboratively to make sure that we have the right semiconductor to enable this data economy, which is growing at a fast pace, and make it efficient and make it environmental friendly. So I really look forward to our discussion today. This is a very interesting discussion because this is the first time I'm hearing somebody focusing on the design aspect because we have been kind of busy talking a lot on the manufacturing aspect of the semiconductor, which is very important, but a lot of value is created on the design side itself, and that is an area where we have like in the intellectual property side, US has kept leadership, and I think it is very critical to pay attention to that and keep focus on design side. So I look forward to our discussion today. Thank you.
Thank you so very much. Allow me to turn it over to Ms. Black.
Thank you. It's such a pleasure to be here and such a joy to be spending a year actually engaging with Perry Worldhouse. This topic is something near and dear to me, in that I've spent most of my career doing emerging technology in the Department of Defense across Navy, OSD, Army. And I think that the design aspect of this is really how we think about owning the future. We spend so much time talking about the crises of today because that is what Washington knows how to do. We know how to have a fight. We know how to pass a law. We know how to, change a policy, but it's mostly tends to be focused around a crisis of today. And I think that we are, in fact, leaders in design, but in order to maintain that leadership and in order to translate leadership in the design for the sort of chips of the future means we need to be informed of what the manufacturing infrastructure of the future will need to be. And that will be different than what we have today. And so ensuring we have a workforce pipeline, ensuring we're exciting future generations, ensuring that we're having challenging conversations about how America has a tremendous aversion to strategic industrial policy. Traditionally, there are so many large topics that the government has to really begin to engage in to support folks in industry like you to ensure that we do, in fact, maintain that leadership into the future. So it's a pleasure to be here, and I'm really excited about the conversation.
Allow me to turn it over to Professor Kapoor for your comments.
Great. Well, it's great to be here as part of an important conversation on the semiconductor industry, and especially the emphasis on design. I used to be a semiconductor engineer before I moved into academia, and I published a number of articles looking at the evolution of the global semiconductor industry over the last 50 plus years. And there are really three key takeaways I want to share with you as starting this conversation that I've learned from my research. The first, which has come through with many of the comments you've already heard, that semiconductor technology is a general purpose technology. That means it's been an engine of what we call as Moore's law that has generated enormous value across many different applications and use cases, but that requires highly skilled workforce and engineering knowledge over time, coupled with significant investments that companies have to make. The second part of the takeaway I found from my research is semiconductor design and manufacturing. In the analogy that I would use is the design is the IP or a recipe that you might use, and the manufacturing is the cooking of that recipe. And so a company to be successful in the semiconductor industry, the core design IP often tends to be a key driver of value in the long term. And finally, the synergies between design and manufacturing are critical to success of any semiconductor business. And as products are getting more complex, whether it's mobile computing, whether it's artificial intelligence, whether it's robotics, the coordination between design and manufacturing is getting more and more challenging. And as we have embraced processes of outsourcing and offshoring for semiconductor manufacturing, and in the current geopolitical environment that we all are in, there are more frictions that companies have to deal with. And this shows up as supply chain bottlenecks, as quality problems, as delays in launching new innovation products. So I think from a policy perspective, semiconductor industry is at crossroads in terms of who needs to do what and what's the level of investments in semiconductor design and manufacturing we need to undertake locally to have a localized ecosystem and minimize the risk coming from the geopolitics of today's times.
Thank you so much. Our panelists have already given us quite a rich panel of information, ranging from potential environmental resource impacts of advanced chip design, to some of the supply chain bottlenecks that need to get resolved, as well as recognition that the US is in many ways the market leader here. So having a conversation about chip design is interesting because we're not starting this conversation from a position in the imminent future of America's losing its edge and it's not leading. Actually, to throw out some stylized facts, I think 60% of the chip design market where most of the highest value add is in fact in the United States. But the other piece, of course, to your point, Professor Kapoor, is that 60% of the assembly, testing, and packaging is in Asia. So as we set out to think about the future, it's not a future about America losing its edge. It's a conversation around design of how does the United States and US firms keep their edge. So I'd like to throw that back to our panelists. The simple question is, what is the design bottleneck? So we know a lot about what some of the manufacturing bottlenecks are. What's the design bottleneck that has you basically up at night wondering whether the United States and US firms will continue to be the market leader in terms of chip design? So what are some of those design bottlenecks as you think about that? Yes, let me turn it over to you first, Mark.
Yeah, I think it's, you're absolutely right, Regina, in that the US has leadership, but the pace of investment, first of all, that's required, I think if you look at, and I'll speak to the high performance side at the, advanced nodes today, the investment required to design products in leading edge nodes, it doubles with each generation of technology. And it's, on the order of about $500 million now. To design a product in an advanced node. If you take a portfolio of products, that's a big investment. And so it requires a lot of investment. The US right now is actually not competitive in how it incentivizes that R&D spend. If you look at countries like Taiwan or South Korea, they provide significant investments on the order of 40 to 50%, versus the US is less than 10%. And so as the investment requirement continues to grow, obviously that's going to weigh into companies' decisions on where they do the design work. So I think it's critical that we find a way to help companies, offset the investment, the growing investment challenge on the design side.
Okay, yes, Rajiv. Mr. Hussain?
Sorry, I was mute. So as Mark correctly said, it's a huge investment in design which is needed. So one of the areas which we have seen that is a public-private partnership in that area, where governments of certain other countries, without naming the countries, they do partner with the private companies to invest in the latest technology, latest process node, or even the latest algorithm. So for example, the best research to find the best algorithm for AI for a specific application, as an example. So those kind of research, are funded. So in my mind, government can do the job which they do best, which investing in future through the academia and through public-private partnership. And that is an area which will help in accelerating the overall innovation and overall investment in the latest technologies when it comes to that end application in the semiconductor. So just like there is a huge investment needed in the manufacturing side to be physically implement the actual chip in a process node, the foundries and the actual manufacturing. Same way, there's a huge investment to find out the right algorithm, the right architecture, and you're really finding the solutions to address the needs of the end application in a most efficient way. And that is an area. The other area, which I believe where academia can help, is if you look at the total number of engineers who get out today, how many of them want to go to semiconductor? And that used to be a much higher percentage if you go only 30, 40 years back. Today, anybody you ask, everybody want to be CS major for one reason or the other. And that is really driven by the perception that, hey, you get the best paying jobs in that segment. not there's some truth in it, but not completely true, because semiconductor is a key area, and some of the best protected, jobs are still in semiconductor. So in some ways, wherein can we incentivize students by having scholarships or things like that to focus more on bringing attention to semiconductor, that will also be useful.
And I would add to both of those comments that while both semiconductor design and manufacturing are knowledge-intensive activities, an important difference between design and manufacturing is a lot of the manufacturing can be automated, whereas design is still a very human capital-intensive process. And as was mentioned earlier, I think the key bottleneck in design for me, in addition to the resources, is the human capital. And as the STEM graduates have diversified into a variety of different verticals, my sense is that the semiconductor vertical has shrunk, and that's creating a huge bottleneck in terms of what expertise we can generate within the US around semiconductor design.
Okay, I'm going to come to you with another question that I think is specifically in your area, but I think hopefully for students listening, there are lots of jobs, there's an interest in having you in this sector, so I hope you heard that loud and clear that this is actually a great avenue for you. You had also mentioned, Mr. Hussain, the issue around public-private partnerships. And now you were at the Department of Defense. And when you think about these public-private partnerships, even if I think of things like DARPA and otherwise, lots of government effort. Is the government failing in some way to sort of stimulate the sort of new design, leading edge or the bleeding edge of chip design? What is the challenge or the bottleneck around these partnerships? Is it a time lag? Like how should we understand why two industry representatives are of the mindset that we're kind of failing on the government side a little bit of not getting the supports in place that will actually keep the United States design edge?
So I think it is maybe our habit to lead with failing. I actually don't consider it a failure. The US is leading, so we succeeded. The US has actually the government has actually subsidized tremendous work in design. We have several federally funded research and development centers that have strong design capacity and capability. The Semiconductor Association has a long relationship with the US government, and the Department of Defense specifically has known that this is a crisis for 20 years. This is not new. I mean, when I started in the government around 9/11, we were talking about semiconductors as a challenge. So what's new is that the rest of the world, the rest of the government realized during COVID, when they couldn't buy new cars, oh, I care about semiconductors. So now we can have this conversation in an environment that takes us out of just the Department of Defense. And I think that's an opportunity to say, we have a historic way that was well aligned to our institutions and habits of the 70s and 80s to incentivize and subsidize these types of activities, that maybe the next generation needs a different set of activities. So I think first I would say, instead of just saying, I'll give you a scholarship to go to college, which you're going to do anyway, maybe give a scholarship and also set up design challenges. Get undergrads of different levels in the system working with grad students and postdocs. Give big prizes for creative new types of design. Give jobs to people who come up with the most creative designs. If you're an industry partner in this relationship, offer them a job on the spot, right? When they actually get out and do something crazy. And potentially something that could lead to something that you could actually, were they to be trained in an industry setting, learn how to make it practical. There are so many different ways that we could make this an interactive two-way relationship with students as they go through the educational process to really focus on something that is a long-term, sort of very flourishing career path. I think the second aspect of public-private partnerships is partnership, both in the government and in industry, is often defined as the government gives industry money and industry does something. That is not a partnership. That is called funding. We do that. That's cool. We're accountants. We know how to give money away. We know how to make it on a spreadsheet. So we know where it went, and we'll ask you for a report at the end of the year. But I would argue that probably knowledge intensive, as you say, fields like this require much more of a relationship around, we're going to push people through industry back out to academia, maybe do a turn through the Department of Defense and see why security on a chip really matters. Show them that that chip is going to go into that ship. And if that chip is then has a backdoor into it, what is the actual failure mechanism that happens? How many people die? Make it real, right? Make national security real. When I started working for the Navy, they sent me out on a ship. And I actually watched kids before they deployed to the Gulf doing certifications. When I went back to the lab, I knew why I was doing my job, right? There were faces to that. That was a relationship that the Navy built with me that no matter what I did after, I always had like a heart there with that. I always had a passion that was related to doing the right thing in emerging technology. I know this is a long-winded answer, but I think the best thing we can do for the design sector in America is really make it a partnership and have everybody actually have some skin in the game in that relationship.
Okay, thank you for that. I realize that we're actually almost at time of Q&A, but I'd love to just do one more round if we could. And that has to do with really, and I'm glad you mentioned this question around partnerships, competitiveness, industrial policy was also raised. And I suppose the elephant, or I should say the dragon in the room would be, China as a competitor, China as a country that is very actively seeking, and actually EU, I mean, every post-COVID or now in COVID, every part of the world is recognizing that these long supply chains had some profound impact on being able to get goods to market. So in that context, if we look at things like open platform software, open platform sort of chips, the RSIC versus ARM, Intel, or the others, how does the United States or US firms keep their edge when other countries are actively supporting their homegrown companies to use open source type of platforms to develop chips and the software and the like? So I don't mean for us to get too techie here, because I don't know that we're a tech audience per se, but to try to understand what this really means, or does it just mean nothing? And then all those articles that say, RISC versus ARM, who's got the edge here? Should we just ignore them all, or is there really something here at stake? And Mr. Hussain, I saw your hand go up, so I'm going to turn it over to you.
Yeah, so when it comes to processor, it's of course, there are a lot of talks about instructions, RISC-V versus ARM versus x86 and so on. Those are all instruction sets, right? And it's not about the instruction set as much in the actual value of the solution, as actually it's the implementation itself. The techniques that you use to implement a high-end processor has a little to do about instruction set. It's all about how did you implement the overall pipeline and overall actual mechanism that you implement. So how high performance and how efficient is your solution? That's what it matters. And this is where the knowledge base and experience and expertise come into the picture, that how good of a product can you implement at the end of the day. So think of it is like, think of it those like a language. Okay, so anybody can have the language, but who writes the best sonnet? That is what it matters, right? So it's similar in a simple man term. Think of it that way. So I believe all these efforts are not as big of a threat. And what we need to keep focus on, how do we keep our edge on the actual knowledge of implementing the most complicated and most high performance, most efficient products. And that's all it matters.
So just a quick follow-up to both yourself and your colleague there. Are you indeed facing a talent shortage?
Indeed.
Yes. Okay. And Mark, can I ask you?
Absolutely. I think that's that's one of the key bottlenecks to the earlier question. It absolutely is a challenge right now in the industry for talent, and it's something that we must address as an industry.
All right. Thank you. It seems like everybody switch your majors now. This is the growth market for you. I'm going to turn to our other two panelists here with just a simple, let's do a little foresight here. Where is this all heading? Based on your knowledge and the areas that you've worked in, where do you think the U.S. firms are going to be going in the future? Do they keep their competitive edge? And if they do, what's going to make that happen? Besides, obviously labor.
I normally tell my students, if I were a good forecaster, I wouldn't be in front of them teaching them. So with that caveat, forecasting, I don't have a crystal ball, but I do think, and I love the way the profound comments that Melissa made around public-private partnership and your follow-on question about the open versus closed debate in the current geopolitical environment. I do think if you go back in history, the formation of Semitech as a response by the government and the industry, at that point it was US and Japan, as the reference says, was a tremendous boost in the competitiveness of America around manufacturing, around the manufacturing ecosystem. I hope, I'm not sure if I can forecast, but I hope we create an equivalent consortium of companies, universities, government agencies, both mission-oriented and doing basic research, to create a Semitech equivalent of what a semiconductor design activity would entail. It comprises openness, it comprises knowledge sharing, it comprises resolving a lot of the bottlenecks that we have got. I don't think the challenge can be solved by one company, one institution, one actor. It really requires a collective response with shared goals and clear objectives. And I do hope 5 years from now, we see a Semitech equivalent of design to raise the competitiveness of the US economy.
I agree completely. I think that this idea, I actually feel quite hopeful in this area. I think it's much more kind of chic to be miserable and depressed and to say the sky is falling. But I'm actually pretty optimistic. This is one of the very few bipartisan areas that we've seen in the US in years. There's a strong agreement across parties. There's a strong agreement across domestic and international, sort of national security focused folks that we need to do something. But I also think that we have to get beyond just saying pour more money in. We have to say, specifically do these types of things. We have to be creative and say, okay, what does a Semitech look like for the 2030s, for the 2020s and the 2030s? We have to create a clear vision that can actually be implemented, that isn't just trust us, we're smart, give us money, because that's not where we are in this debate. So from my perspective right now, the challenge is actually getting together the design sort of industry with, I think, academics who do truly understand the history of this, but then also with some folks who understand the bureaucracy to say, what is the future vision? What does win the future for us? What does bring that to like a place where we know that we can maintain leadership in 2030, 2040? But I think as long as we're just saying, give us more money, we're smart people, trust us, that is not the moment that we're in. People want to understand, how does this help Americans flourish? They are investing in you. They, the American citizen who is paying taxes, is investing in us. And they deserve to have a business plan, right? One that they can actually understand how it can be implemented. And I think we've fallen short on that. And I think it's doable. And I hope that we get there.
I'm delighted we're ending, before we shift to Q&A, with an optimistic note, which is one that makes an appeal for the development of a design ecosystem in the United States. And with the promise that should that come to be, the competitiveness of US firms will remain at the forefront as it currently is. And we will be able to really move forward as well, it sounds like, with better cooperation, not only between business, but between business and government, toward a shared goal of remaining on the leading edge in this important industry, not just for business, but also for government, military, national security, cybersecurity. There's a lot of chips in this room right now, in fact. So I think without further ado, what I'd like to do is open the Q&A right now. If any of you in the audience, of course, just raise your hand if you're here in front of us. And otherwise, I'm getting some questions in as well from over here on the little iPad. So maybe what we can do is start first with some questions from our audience here present. Yes.
Can you hear me okay? Because part of what I'm trying to do is model how loudly you have to speak when you come up to this mic. So I wanted to pick up on Melissa's point about winning the future. And I want to hear everyone on the panel maybe do a little bit of guesswork, prognostication on what winning the future means in a substantive way, and what the combination of coordination and work between government and private sector looks like if you can establish what winning the future actually means. So I would like everyone to answer that question.
All right, and then
Thanks.
again, for our panelists who are joining us remotely, just raise a finger and I will know to come on over and call you into this conversation. So yes, Mark.
Yeah, I
And
think
same for you, just
actually,
raise-
yeah, and I think Melissa's comments were well founded. I think to me, what winning looks like is a partnership where we can establish standards, and even I'll say in one area around security, there really needs to be standards that we as an industry align on. And in many ways, I think the government has a role to play to help the industry figure out what standards make sense. And then we as an industry know how to take that and then develop it into solutions.
Okay. Yes, Mr. Hussein.
So to me, the winning the future means we're through the partnership between the public and private partnership, we can really lead the industry. So in other words, we are leading in industry when it's come to communication, whether it's 6G or the next wireless connectivity, whether it's the best highest bandwidth solution for our data networking, whether it's the best compute, most efficient, power efficient, environmental friendly compute solution, mainly addressing the needs of the data infrastructure, which requires a lot of data-centric compute. Other words, or whether it's the most efficient, battery operated type of IoT devices and so on. So if we are leading those technologies and providing, in other words, guiding the rest of the industry together, I think that will be the winning the future. And also we are generating enough resources, which means talent pool, to be able to sustain that ongoing growth and development to scale.
Thank you. Let me now turn it over to another question here.
Hi there. I'm Theo Milanopoulos. I'm a postdoctoral fellow here at Perry World House. I did political science, and I probably should have done actual hard science based on this conversation. I had a question. I hate to be the skunk at the garden party on a design ecosystem, but I see at least three potential barriers that I think limit competitiveness. One is around funding for higher educational institutions, to the extent that they are incubators for this kind of work. You can see that there are barriers and declines in funding for that. Maybe not as much in STEM, but increasingly, as one part of the university suffers, perhaps others will start to as well. Another is about immigration policy and the extent to which we can actually recruit and retain the best in the world, and not only to come here and study here, but then also remain here. And the third, in terms of a public-private partnership, is around access to security institutions and other things have tremendously high barriers in ways that don't facilitate the kinds of exchanges that could potentially be productive. So I'm wondering what both members of the industry and the public sector are doing to kind of try and address some of those barriers.
So I will say I was recently, I worked for the Center for Security and Emerging Technology for a few years that has published a tremendous amount. If you're interested in sort of this intersection between immigration and the semiconductor industry, they've produced a lot of work. Will Hunt will actually be giving a talk next week, I think, or a couple of weeks from now. So I think I'm not going to go deep into that. I think immigration policy is probably the hardest of those three in the current climate. And so I'm going to leave that to the side. I'm not an immigration expert. I apologize. I'm a scientist. There's never been an American in any lab I worked in. So what I will say around universities, I think specifically in stimulating these types of educational environments, I do believe that is a partnership and a relationship we need to develop. But this is a strategic area that we need both for national security, defense-oriented national security, as well as economically focused national security. Then I do think we need to provide well-funded environments that have real sort of challenge associated education, experiential education, co-op education, I think is a great older model that works really well in these types of environments that brings industry and academia, I think, into a different relationship where it is a part of the educational experience. And I do believe that we need to truly subsidize education in areas that we've decided are of strategic importance. I actually think we should probably do it much more broadly than that, but that's not what we're here to talk about today. I also think that from a government perspective, we are fast coming to the end of believing that the market will solve all problems, right? That competitiveness will just simply happen without some kind of intervention, specifically in areas like this, at least on the manufacturing side where the margins are low and you need high volume, right? On the design side, though, I really think this is, if we have the best people in the world, then why aren't we, if we believe that talent is what matters and we want to develop the pipeline that is sustained and has the best talent in the world, because that will maintain your leadership. I believe a part of what you actually have to do is start clearing people as they come in as freshmen. We're going to give you clearances. You're going to be able to go to Kirkland Air Force Base or to Oak Ridge National Laboratory or whatever the defense or national lab is that's near you and leverage relevant infrastructure, talk to users, understand security risks. You don't have to give them top secret clearances. You can do a lot on these in these environments with a basic secret clearance. Why don't we just start clearing people, start clearing them out of high school? I think that if you actually clear people young, it's much easier to keep them cleared than if you show up 10 years later and say, you really shouldn't have smoked that pot when you were 20. Like, it's just easier to get them before they started smoking pot. Like, it's going to be a problem, man. If you want to do this, like, smoke less pot. I mean, it's easier to say that to a 19-year-old than to 29-year-old. And like, we're going to make you write down every time you smoke pot since you were 18. Like, that's awkward. So there are really simple things that we can do as the government to focus on the workforce. And if we have the best workforce and they have an engaged, competitive, intellectually challenging environment that they are sunk into early, they're going to be bored when they go just chunk code at Google. They're not going to want to do that. Oh, I got a massage. Yeah, but I worked 17 hours a day and they owned the ideas I had in my sleep. Like, that's not what I want to do, but I loved what I did when I was really designing the future of all of the electronics in the world. Like, we just need a better sales pitch. Seriously, it's a cool area. You need cooler people talking about it.
Thank you.
You got me. That's a shame.
Let me ask you to just hold one moment so I can take a question from the magic iPad over here. So this is a manufacturing question. And it says, should the US government and private companies do more to move manufacturing back to the United States, or have we already lost that battle? Does the US have the will and the investment desire to bring manufacturing back home? Yes.
I can give you my perspective, again, not from a government perspective, but from a strategy professor who studies the industry perspective. The easy answer would be yes, right? I think the more nuanced answer would be, this can't be a one-size-fits-all approach to policy. I think this discussion about make or buy as a question around manufacturing, in my personal view, is misinformed in the sense that it misses many other opportunities from a strategy perspective that's not quite internalized. I'll give you an example. That many semiconductor companies over the years may be outsourcing, but they also make certain types of semiconductors internally. And they also sell certain types of manufacturing capacity to external players as well. So I think for me, whether we should move things in or we should keep things as is, requires a fundamental understanding in terms of how the different semiconductor technologies, how different businesses depend on tight coordination between manufacturing and design. And second is, what's the market structure for the supply side and the demand side that each of these products represent? If you are a monopolist in any given semiconductor market, you have enough leverage to outsource and do it well. But if you're part of a competitive environment, there are 5 or 6 other competitors who are trying to go for the same outsourced supplier, you are more likely to face the bottleneck. So to be able to anticipate both the challenges of coordinating across supply chain and the differences in terms of technology complexity and the competitive structure, can probably offer a more informed view of that question.
Thank you so much. I just want to see, yes, Mark.
Yeah, I actually, I think just adding a few comments. I mean, it's important to realize, my answer would be absolutely the U.S. Can compete here. I know there's a lot of talk about how everything's moved out, and certainly that's true. I mean, a lot of the capacity is now elsewhere. But let's remember, I mean, for the last 20 years, Samsung has had a facility in Austin where it actually manufactures leading edge memory and logic. Recently, both TSMC and Samsung have announced significant investments in the U.S. where they're going to bring leading edge capability. A big part of the IP that goes into that manufacturing is in the tool set, and actually, very large portion of the tool manufacturers are based in the U.S. So I think it's very clear the U.S. has the capability to do this. Part of it is definitely will, and part of it is setting a strategy that, to be honest with you, I think even these international foundries realize the importance of diversifying their manufacturing outside of their home countries. They see the need and the importance, given the size and the impact of the design houses in the U.S. They also see the need for diversification. So I do think that there is a play here for the U.S. to continue to be a manufacturing leader in the industry.
Okay, thank you. Let me turn it now over to this gentleman.
Hi, thank you. I'm Nima. I'm a PhD student in electrical engineering working on quantum computing.
What are you working on?
Quantum
computing. Okay.
And also, yeah, just to piggyback off what Dr. Flog had to say about partnerships with the government. We're funded by the DoD. And from that, we've really leveraged from a close partnership with the Army Research Office. So it really does make a difference to have that partnership, not just at the funding level. But I do have a more technical question for, I guess, particularly the semiconductor industry people here regarding, coming to the end of Moore's Law and finding new materials that could replace silicon. How much are large foundries? How much effort are large foundries doing to move their manufacturing in that direction? And also, what changes in terms of the supply chain? How much more reliant is the U.S. becoming on other on resources from other countries?
So can I just clarify? There's two questions there. One is,
There's one question.
well, there's one around
sorry, yeah.
there's one around new materials and the use of new materials. First, focusing particularly on silicon and what the new materials might be doing in terms of U.S. competitiveness. And then the second one is how competitive is the U.S. versus others in terms of manufacturing? Is that
Well, no,
correct?
in terms of I guess, let me rephrase that. In searching for those materials, how much more reliant is the U.S. becoming on other countries to attain those resources?
Okay, and I saw buried within there as well a question about whether Moore's Law is coming to its end. So that's the
Well, it
that's
is.
the
That was more of a statement.
that's
rather
always
than
the
a
great.
question.
Okay,
We agree that it
we
is.
agree it has. Okay.
That's a question we've been trying to answer for 40 years.
Okay, all right. So there's quite a few there, but we're going to defer to the technical questions to the corporate folks on the virtual side of things.
Sure, I can start off and let Raghib add to this. But on the material side, I think absolutely more needs to be done. I think usually what I would say is in an environment, in a free market, what traditionally happens is businesses are probably going to spend more of their time focusing on nearer term ROI. And this is where important research institutes, IMEC is a great example, that does amazing research on future materials. And this is a really good area. And Semitech was mentioned earlier, that in years past had done some of this work. There needs to be sort of a partnership again, where the industry as a whole can sort of collaboratively do this type of research work, working with universities, and through other institutions. So they're definitely, I think it's important that we not just rely on the foundry manufacturers to do that work. It needs to be brought in from elsewhere. The important thing to also realize is it's not just about fab technology. As we look forward, packaging technology is becoming more and more critical, and you'll see that in roadmaps showing up. And that is a whole new sort of playground where a lot of new innovation needs to happen. And that's a lot of that is materials. A lot of it is reliability type modeling, all really, really solid research that needs to happen. And we really need to find a way to sort of jumpstart that work.
So Mark covered very well about the need of the research in this area and the fact that we cannot depend on foundries only. One of the things which I wanted to reemphasize and put more emphasis on, that this like a quantum computing and post quantum compute cryptography, for example, those are the areas where a partnership on research with the academia and industry and government works really well. Because the problem with this, most of the businesses is focused on the ROI of the investment, and if something which is 5 years, 7 years, 10 years later, it is hard to justify, hundreds of millions of dollar investment in that. And that is why many times it is kind of not ignored, but overlooked or delayed by the just open market competition to adapt or to invest in those areas. These are the areas which are pure research topic, but it's beneficial to the entire community, to the entire industry in the longer term. For example, finding a material which is captive to one country, which is not willing to participate with the rest of the world, is not a good idea, actually. No matter how good is that material, is not a good material, right? Versus finding something which is more broadly available and can benefit the entire world. That is probably the right thing to do. So this is where the combination of the knowledge, what my colleague said, that bureaucracies and the geopolitical situations, as well as technology, they all have to work together to find the right solution. So this is a perfect area where partnership works best.
Okay, and then I believe you wanted to just jump in.
I just want to add one more thing to this, because I think it's such an interesting question around new materials, where we fund a lot of basic science in America and we focus a lot on talking about basic science. But I think what we've lost that we used to do really well was ensure that basic science was informed by practical goals. The moonshot, we knew we were going to the moon, right? We had to get through an atmosphere. We had to get squishy, wet humans back alive. Like, we had these really tight parameters. And then we did lots of basic research that enabled the engineers to engineer something that worked. I think a really interesting partnership in this area around especially new materials and some other things would be for industry to help us craft some really good questions that were basic science questions answered in those areas. Industry would actually know how to leverage them and make practical progress. And we sort of eschew focusing on applied research, but I actually feel like if we got practical guidance on the goals from the industry that would actually need to apply them, then the work that you're doing and that's being done in new materials and other areas could feed really seamlessly into that, and we would harvest more effectively. So I think the government could actually fund more effectively if it were informed by some of these more practical goals. And I think that's a future conversation that the government and industry should really be having with Congress, because right now it's not easy for us to legally create those types of relationships, which is why we default to public-private partnerships like Semitech. I think there are other models to do it. And I think it's really important to think about, we may find synthetic ways to create some of these materials that right now we're heavily dependent on our competitors for access. I think we really need to lean hard into that.
Thank you.
Okay, do I have time for one more question? I believe I do, yeah. Okay, let me go ahead with that. Just want to make sure we have our kind audience that's listening in. We should not just give them one question, we have to get at least two. So let's go ahead with that. This one's a very long one, but I'm going to try to sort of cut this back, because this is one of our first questions, which asks, what parts of the United States can be most competitive in increasing chip capacity, design, and production? So here, I suppose we are talking about the potential of new materials as part of that competitiveness. What is it as well around the way the market is changing? How is the market changing for semiconductors, whether it's customization or otherwise? Where does the United States have its edge? And so I'd be curious if you could maybe address that issue of where it is, how the market itself is changing, and where you think your expertise and specialization can make the biggest difference. Yes, Raghav.
So one of the good thing I believe is happening, as I said in my initial remarks, that the whole world is being driven by data, which means that a lot more data is needed to be processed, to be stored, and so on and so forth, which requires the different level of technologies. For example, kind of compute that we will need is a completely different type of compute, is like a data-centric compute, which is a heterogeneous compute of various kind of processors involved. Right now, when it comes to those kind of technologies, US companies have leadership in the world in that. Similarly, when it comes to data bandwidth, when it comes to like a optical interconnect, 400 gig PAM4 or 400 gig, ZR plus type of interconnect, moving huge bandwidth within the data center or from data center to various edge data center and so on. These are hardcore complex technologies, and we have the country has the leadership. Actually, Marvel has the market world-leading products in that area, as an example. Similarly, when it comes to various kind of technologies, when it comes to storage and so on, US have leadership. So in my mind, the capabilities that we have, actually, we are leading. So I'm an optimistic and positive on this side that we have right now the design edge and we have technology edge. We just have to make sure that we have pipeline for the next generation to keep driving on that and keep our leadership in moving forward.
I would
Thank
just
you.
add, I think that from a production standpoint as well, one thing we need to get serious about is what are the goals of an actual industry policy, right? What kind of capacity do we need to serve Department of Defense needs? What type of capacity do we need to serve the most critical industry needs? And we do actually have to prioritize some things, because you can't bring all the manufacturing back. You can't bring everything in-house inside the country, but you can actually begin to think there's a certain baseline capacity that I need to subsidize across all of these aspects of the supply chain. In the design space, we really want to try to lead, but maybe in the capacity of sort of production, I need 20% of my supply chain here or something. But these require actual strategic industrial policy that engages industry and engages the Department of Defense and a lot of other actors across government. And I think that's missing. And I think that's going to be a challenge if we don't get serious about it.
And the only other last point I'll make is one other thing to our advantage, given that we have such a lead in the design space, especially again from leading edge applications and compute, more of the value add and the decision making around making a solution is moving into design. You don't just design a single chip, send it to the foundry and they build it. It's now usually multiple chips, IP from many different design companies potentially through a packaging solution. And so the decision and the architecture of how you build that is becoming more and more important in the solution. And the good news is with our design leadership, we would control and continue to drive that.
Okay, so it looks like as if we're ending on a somewhat optimistic note of potential. I don't know, Professor Kapoor, if you have any final comment. So I think what I'd like to do then, if you'll just bear with me, is first thank all of our panelists. So thank you, Melissa, Mark, Rajiv, Rahul, for sharing your insights and taking the time with us for this very exciting and really fast-moving target, despite all the challenges of cooperation and collaboration across borders and government agencies and business. I'd also like to thank our audience for joining us today for this important session of The World Today. Before we end, I would like to just give you a heads up on two upcoming events. On Thursday, February 24th at 4 p.m., the Army War College will be joining us here. And this event is going to be in person as well as live streamed. And then on Tuesday, March 1st at 4 p.m. here at the Perry World House, we're going to have the next edition of The World Today. And our topic is going to be Global Justice, the Struggle for Women, Human Rights. And this is featuring our Associate Dean for International Affairs at the University of Pennsylvania Law School, Ranjita de Silva de Awis, and our very own Perry World House Executive Director, LaShawn Jefferson, who was here moments ago but went upstairs. Okay, and she's going to discuss together the importance of the United Nations Convention on the Elimination of All Sorts of Discrimination Against Women after 40 years of its inception. And as always, you can access recordings of this conversation in the Perry Worldhouse YouTube channel. And you can also find out about all of our great events we have planned for the next semester by joining our mailing list and following us on Twitter, Facebook, and Instagram. We will drop all of the links for all of these into the chat. And for those joining us in person, please go ahead to the Student Lounge, which is, I believe, that way, for a grab-and-go snack. And thank you, all of you, virtually and in person, for being with us today. And thank you again, panelists, for a great, provocative, and also inspiring conversation.
Thank you.